Module 2, Quality Health, Safety, and Environment Studies. Introduction to Waste Management in Oil and Gas Operations. The generation and proper management of waste in oil and gas operations are of significant concern in the field of quality health, safety, and environment, QHSE. Waste from exploration and production (E&P) activities includes a variety of substances, each with its own potential environmental and health risks. Understanding how to classify and manage this waste is essential to ensuring the safety of workers and the protection of surrounding ecosystems. Waste management begins with proper classification. In the oil and gas industry, E&P waste is typically divided into hazardous and non-hazardous waste categories. Hazardous waste includes materials such as drilling fluids, produced water with high chemical concentrations, and spent chemicals. Non-hazardous waste might include materials like domestic refuse from camps or biodegradable kitchen waste. Managing this waste involves a series of steps, including waste minimization, segregation, storage, transportation, treatment, and disposal. Effective waste management programs not only protect the environment but also demonstrate a company's commitment to sustainable operations and corporate responsibility. Classification of E&P waste. The classification of E&P waste is crucial in determining the appropriate method of treatment or disposal. Waste can generally be categorized as follows. 1. Drilling waste. This includes spent drilling muds, drill cuttings, and additives used during drilling operations. 2. Produced water. Water that is brought to the surface during oil and gas extraction, often containing hydrocarbons, salts, and heavy metals. 3. Workover and completion fluids. These are fluids used during well servicing and completion activities, which may be chemically treated. 4. Waste oils and lubricants, spent hydraulic fluids, used motor oils, and other oily residues. 5. Chemical waste. This includes spent or expired chemicals used in various stages of oil and gas production. 6. General waste. This encompasses domestic waste, packaging materials, and office-related refuse from oilfield camps and facilities. Proper classification ensures that each type of waste is treated with the necessary precautionary measures and also informs decisions on whether recycling, treatment, or disposal is the best course of action. Treatment methods for oil and gas waste. Oil and gas companies employ several treatment methods to manage waste, depending on the type of waste and the regulatory requirements. Key methods include 1. Thermal treatment. This involves using heat to treat waste, such as incineration or thermal desorption. Thermal methods are effective for hydrocarbon-contaminated waste, breaking down organic compounds into less harmful forms. 2. Biological treatment. Utilizing microorganisms to break down organic waste is common in treating oily sludges. Bioremediation, for example, uses bacteria to degrade hydrocarbons. 3. Chemical treatment. Chemicals may be used to neutralize hazardous components or to facilitate precipitation and separation. 4. Physical treatment. These methods include filtration, centrifugation, and sedimentation to separate waste components by size or weight. 5. Solidification and stabilization. These processes involve converting liquid waste into solid forms to prevent leaching into the environment. 6. Secure landfilling. Properly designed landfills with impermeable liners are used to isolate hazardous waste from the environment. A combination of these methods is often used to meet both environmental standards and operational efficiency. DPR and FIPA guidelines. In Nigeria, the Department of Petroleum Resources, DPR, and the Federal Environmental Protection Agency, FIPA, have established guidelines to ensure that the oil and gas industry operates in an environmentally responsible manner. DPR guidelines are specific to petroleum operations and outline standards for waste management, environmental impact assessments, emissions control, and oil spill contingency planning. Compliance with DPR regulations is mandatory for companies seeking to maintain operating licenses. FIPA guidelines provide broader environmental protection measures applicable to all industries, including oil and gas. These guidelines include provisions for pollution control, waste management, and environmental monitoring. The enforcement of these regulations ensures that oil and gas companies adopt best practices in environmental stewardship, including proper documentation, regular audits, and the implementation of corrective measures when necessary. Impacts of oil and gas production on the environment. Oil and gas operations, though critical to economic development, can have serious environmental consequences if not managed properly. Key environmental impacts include 1. Oil spills, accidental releases of crude oil during drilling, transportation, or refining can cause extensive damage to marine and terrestrial ecosystems. Spills contaminate soil and water, harm wildlife, and destroy habitats. 2. Gas flaring, the burning of excess natural gas during extraction releases carbon dioxide, methane, and other pollutants into the atmosphere. Flaring contributes to air pollution and climate change. 3. Water pollution, discharge of produced water and other waste into surface or groundwater sources can lead to the accumulation of toxic substances, posing health risks to nearby communities. 4. Land degradation, construction of roads, pipelines, and drilling sites leads to deforestation, soil erosion, and loss of biodiversity. 5. Noise and air pollution, heavy machinery, transportation, and flaring operations contribute to air and noise pollution, affecting both workers and residents in nearby communities. Mitigating these impacts requires strict adherence to environmental regulations, continuous monitoring, and the use of advanced technologies. Modalities for mitigating oil pollution and flaring. To address environmental damage caused by oil spills and gas flaring, several mitigation strategies have been adopted. 1. Oil spill contingency planning. This involves the development of detailed response strategies, including spill detection systems, containment booms, schemas, and cleanup protocols. 2. Use of bioremediation. Applying microbial cultures that consume hydrocarbons can help restore oil-contaminated sites. 3. Improved operational practices, regular maintenance, proper storage of chemicals, and the use of blowout preventers can reduce the risk of spills. 4. Gas utilization projects. Instead of flaring, companies are investing in projects to capture and utilize associated gas for power generation or as feedstock for petrochemical industries. 5. Regulatory enforcement. Governments must ensure compliance through inspections, penalties for violations, and incentives for cleaner technologies. These modalities not only protect the environment but also enhance the sustainability and reputation of oil and gas companies.